Hi there, I am Andrea Brancaleoni, a security researcher at Doyensec. Doyensec is an independent security research and development company focused on vulnerability, discovery, and remediation. As a part of our continuing security research journey, we started developing an internal tool to speed up GraphQL security testing efforts. Since we love open source, we released Inql. Inql started as a Doyensec internal research project. It was initially released as a GraphQL recon tool, and lately it got a lot of attention for its extensive integration with other tools such as Burp, Python, Jython UI, and it got lately also a SQL map integration. It can now detect denial of service statically and dynamically, and it can even detect CSRFs dynamically. As you can see from the right part of the slide, it went through a lot of development lately, and it changed the structure quite a bit. But what it is GraphQL? GraphQL is a query language for APIs. GraphQL provides a complete description of the data in your API and gives clients the power to ask what they need and nothing more. GraphQL APIs are organized in terms of types and fields, similarly to the Golang structs. As you can see in this example, the type project has home, tagline, and contributors fields. The first two being strings, and the last one being another complex object that can be defined as a type. GraphQL allows you to access the full capabilities of your data from a single endpoint and to query for specific types in your database. In this example, you can see that this query is asking for a project that is having a given name, but it's not requesting the full object. It's requesting only the tagline attribute. From this query, you can get a predictable result in the form of a JSON response. As you can see, the response is containing a project which tagline is the content of that object attribute. But what a GraphQL request looks like. As I told you, the requests are HTTP requests on a given single endpoint. A basic GraphQL request takes the form of an HTTP post on a single /GraphQL endpoint. Why usually it is requested as an application JSON, usually many other content types are accepted by the application server. On the other hand, the response usually takes the form of a single application JSON with only the queried fields. Typical GraphQL vulnerabilities includes missing authentication, denial of service, information exposure, and system-wide cross-site request forgery. For what concerns missing authentication, since GraphQL does not enforce any specific authentication method, it is the developer due to implement something specific for his application. For what concern denial of service, given the attacker can precisely control the query format, it can issue problematic queries which may cause a denial of service on the server. For information exposure, instead, allowing the user to query for a specific field at any given time and providing a full implicit documentation of the APIs enables the attacker to extract usually confidential data. For CSRF, GraphQL middleware usually accepts many different content type and HTTP methods. Together, this allows the attacker to bypass most of the CSRF protections. Inql was initially created as a recon tool, and then lately added a lot of other capabilities. For example, the Burp integration. Inql gets its name from Introspection GraphQL. The tool allows you to query the introspection endpoint and to generate APIs documentation from a black box perspective. Inql is now included in the Burp App Store. The black box approach allows you to quickly navigate the application APIs without the source being available. While created for a black box usage in mind, it can be used by developers too, to explore the APIs. Inql was born as a CLI tool, and it never forgot about its origin. Inql can now be used from the command line too, and it can generate the same queries from the endpoints. This integration with the command line allows the developer to generate query introspections and then feed it as a file to the Burp plugin. But Inql is now tightly integrated with Burp 2. It now includes an active and passive scanner integration, which allows you to detect GraphQL endpoints in applications automatically. Inql has gone through several iterations. The second version of Inql included a lot of niceties for what concerns send to repeater capabilities. As you can see from the right side of this slide, send to anywhere capabilities allows you to send every query to the repeater or anything else inside Burp and outside. It allows to generate HTTP headers, including authentication headers, and also allows to add custom headers during the introspection query. As you already seen in the previous slide, you can use the send to repeater with custom header, but send to repeater allows you also to check for CSRF's vulnerable endpoints through these send to post form URL encoded and send as get query parameter. One other feature is sending to repeater and to GraphQL from the repeater itself. The GraphQL integration allows you to check for queries documentation easily. But the integration is two-way. You can even send from GraphQL to the repeater. While version 2 represented a huge milestone for even the integration within the Burp App Store, the version 3 included a new denial of service explorer capabilities. The DOS Explorer is composed of two components. The first one is the cycles detector and the second one is the request timer. They both merge to detect and demonstrate denial of service, both statically and then dynamically. Cycle detector is available in command line and it can also be enabled in the Burp UI. If you are lucky, in a matter of seconds, it can find all the cycles inside your project. You can also test for these cycles within the GraphQL included extension. Luckily, as the cycle detector is detecting cycles inside graphs, it can even never exit. The DOS Explorer theme is then completed by the request timer. The request timer allows you, through the Burp interface, to detect the time required to execute a given GraphQL query. It is on by default, and it records all the execution times of all the queries that are going through Burp. This is useful for demonstrating denial of service dynamically. In fact, denial of service found by the cycles detector may even not be exploitable due to protection introduced by developers. As you can see, the system update query is getting a long time to get executed. And going through the queries, you can check that it took 30 seconds to execute. In V4, we are integrating everything and bug fixing as much as we can. Python package is still running strong. There is a Jython UI, which is mainly deemed as an API explorer for the guys that are not using Burp. GraphQL console is still quite a huge value, since it allows you to have a GraphQL console when the server is not allowing you to use it. And we are now even including a SQL map integration. In fact, every query will be compatible with SQL map format for automatic exploitation. As you can see on the right, we are exploiting a SQLi inside the query without even touching the code. And this is time for question time. Leave a comment below and your Bitcoin manager will answer all your questions. You can contact me at doyensec on Twitter, and if you want to contribute to this project, please pull request on GitHub.